You know that cup of coffee you're holding? It's way more than just a morning ritual. It's actually the final piece of this huge, high-stakes agricultural puzzle, a really delicate balancing act that farmers all over the world have to perform. So let's dig into what it really takes to get from a tiny little seed all the way into your cup. Okay, first things first. Not all coffee is created equal. The whole world of coffee is pretty much run by two main species. On one side, you've got arabica. Think of it as the high-quality, sensitive artist of the family, hailing from the highlands of Ethiopia. Then, on the other side, you have robusta, its tougher, hardier cousin that just loves warmer climates, like in Côte d'Ivoire. These two right here, they set the stage for everything else.
So, how in the world do you actually grow these things? Well, the very first part of a farmer's challenge is just finding the perfect home. And that really boils down to two critical factors: the climate and the light. For that premium arabica bean, the conditions have to be just right. And I mean, we are talking about a super specific temperature window. It can't get any colder than 59 degrees Fahrenheit and no hotter than 77. It's this tiny little thermal sweet spot that basically dictates where on the entire planet this coffee can even hope to grow. Now let's look at robusta, and you can see the difference right away. This plant likes things much, much warmer. It thrives in a range between 75 and 86 degrees Fahrenheit. That hardiness is exactly what lets it grow in places that would be way too hot for the delicate arabica.
So how do farmers actually find these perfect temperatures? It's fascinating, really. They use this relationship between latitude, so how far they are from the equator, and elevation. As you move away from the equator's heat, coffee can actually be grown at lower and lower altitudes to stay in that ideal temperature range. It's all about finding that perfect balance, whether it's way up on a mountain near the equator or down in a valley much farther away.
You'd probably think that more sun is always better for a plant, right? Well, get this. It turns out coffee leaves only need about a quarter of the available sunlight in the tropics to work at their absolute best, just 25%. So what happens to all that leftover energy? Well, it doesn't just go away. It has a very specific and potentially dangerous effect on the plant. So here's the deal. All that extra sunlight basically tricks the tree into producing way more flowers. And more flowers means the potential for more coffee cherries. Now for a farmer, more cherries sounds amazing, right? But what it really does is set up this dangerous imbalance inside the plant, kind of like a biological debt that is absolutely going to have to be paid.
All right, on to part two. We've talked about the outside environment, so now let's look inside the plant itself. It all comes down to what a coffee tree eats, and believe me, this is a game of some seriously high-stakes nutritional math.
Just like us, plants need a balanced diet. For coffee, the three most important nutrients, the ones in these in huge amounts, are nitrogen, phosphorus, and potassium, or NP/K for short. You can think of these as the protein, carbs, and fats of the coffee world. If you're low on any one of them, it can absolutely cripple the harvest. And this right here is where you see the real cost of a harvest. For every single ton of green coffee beans that leaves the farm, the soil loses a whopping 90 pounds of nitrogen and 80 pounds of potassium. Those nutrients are literally locked inside the beans you're buying, and they are not coming back. They have to be replaced.
So how do you put them back? Well, a farmer really has two choices. To replace the nitrogen from just 1 ton of coffee, they'd need to add a massive 5,000 pounds of organic compost. Or they could use just 650 pounds of synthetic fertilizer. The crazy thing is, the tree doesn't care where the nutrients come from, but for the farmer, the logistics and the costs are worlds apart.
And that brings us to the final part, the high-stakes yield game. This is the moment where everything we've talked about, the climate, the sunlight, the food, it all collides. This is what determines whether a farmer has a great year or a total disaster.
The final yield is basically one long multiplication problem. It starts with how many trees you've got. Then you multiply by the number of vertical stems on each tree, then the branches on those stems, then the cherries on the branches, and finally, the beans inside each cherry. A weakness in any single link in that chain can just tank the entire harvest.
Now, this right here is the single most important rule of coffee biology. When things get tough and resources get scarce, the coffee tree makes a choice, and its choice is always the same: feed the kids. The cherries, which hold the seeds for the next generation, get first dibs on every available nutrient no matter what. And the result of that rule? It's brutal. If the tree has too many cherries, remember that extra sunlight, and not enough nutrients in the soil to feed them all, it will start pulling nutrients from its own body to feed the fruit.
It's a process called dieback. The tree literally sacrifices its own leaves and branches, destroying its ability to produce a crop next year, all for the sake of this year's cherry.
This also leads to another massive problem, a boom and bust cycle that we call alternate bearing. A huge harvest one year completely exhausts the tree, so much so that the following year it can barely produce anything at all. It's like an athlete pushing for a world record and then needing an entire year off to recover. For a farmer who relies on consistent income, this is an absolute nightmare.
So let's bring this all home. This whole process, from start to finish, is a masterful balancing act. It's an incredibly complex puzzle that requires a ton of skill and, yeah, probably a little bit of luck to solve. You see, a successful coffee crop isn't about getting just one thing right. It's about getting everything right, all at once. The farmer has to be a puzzle master, perfectly fitting together the plant's genetics, the climate, the sunlight, the nutrition, their own management style, and the constant fight against pests and disease. If even one single piece is out of place, the whole thing can fall apart.
So the next time you take a sip of your morning coffee, just take a second to think about this incredible dance of biology and agriculture. Knowing the immense challenge, the razor-thin margin for error that farmers face every single season, ask yourself, what does it really, truly take to create that perfect cup you're holding in your hand right now?